Okay guys, welcome to problem 7. And in problem 7 we are to obtain the Wronskian of sin x, 2 cos x, and the combination 3 sin x plus cos x. So we are also to comment on the Wronskian of the above solutions. So let's begin. So to find the Wronskian, I'll just develop my Wronskian matrix immediately. So the Wronskian matrix for sin x, 2 cos x, and 3 sin x plus cos x. So this is how the matrix will be. So the matrix will, first of all, the first row I have sin x, okay, then I have the derivative is what, cos x, and the derivative of cos x is negative sin x. Is that okay? So the next term is 2 cos x. So the derivative is negative 2 sin x, and the derivative of negative 2 sin x is what? Negative 2 cos x. Then finally I have 3 sin x plus cos x. The derivative is 3 cos x, okay, then minus sin x. So the derivative here is negative 3 sin x minus cos x. So let's see what this determinant will evaluate to. So the next question is, how do we expand these determinants? Well, I will advise you to expand these determinants from this particular column, okay, the third column, plus, minus, plus. So we're going to expand it downwards or upwards, whichever way you want, but I'm going to expand it downwards. So expanding it downwards, starting with this term, I have 3 sin x plus cos x, okay. So the minus for these elements, we have cos x, negative 2 sin x, we now have negative sin x, we now have negative 2 cos x, okay. And we now have minus, permit me to arrange it in this way. So minus, I have 3 cos x minus sin x, and the minus for these elements, we have this, and this, okay. These are the minus for these elements. So we have sin x, 2 cos x, okay, and we have minus sin x minus 2 cos x. Are we good? And finally we have this particular term over here. So it's a plus into this term, negative 3 sin x minus cos x. So when we take the minus for these elements, which is these ones over here, sin x cos x, sorry, we have sin x cos x, now have 2 cos x, and of course minus 2 sin x. So we are going to start with the expansion from the Wronskian. So this particular one stays as it is. I have 3 sin x plus cos x. So when I expand, cos x times minus 2 cos x gives me minus 2 cos squared x. Then sin x times negative 2 sin x times negative sin x gives me still what? It still gives me okay, that's 2 sin squared x. So this is minus 2 sin squared x, okay. So please take note of that. Then we now have minus this term over here. We have 3 cos x minus sine x, okay, then into, so let's expand. Sine x times minus 2 cos x gives me minus 2 sine x cos x, then minus this term times this term is going to give me a plus 2 sine x cos x, because when you do this times this, it actually gives you minus 2 sine x cos x, but because you're still subtracting these minor diagonal, minus times minus will be plus, and this will be plus 2 sine x cos x. So finally, for the third term over here, we have plus negative 3 sine x minus cos x, then into, so sorry, I think there was a mix up over here, and it's actually arranging by itself. So we have for this place, sine x times minus 2 sine x is minus 2 sine squared x, then minus this term times this term is minus 2 cos squared x. Is that okay? So this is where we want to consider from and see what we get. So this is equal to, we have 3 sine x plus cos x into, so minus 2 sine square x minus 2 cos square x minus 2 sine square x is still the same thing as you saying minus 2 into cos square x plus sine squared x. Is that okay? Then this whole term, because of this part resolves to 0, okay, because they are similar algebraically, so it resolves to 0. So 0 times this term is 0, so what we just have is this term here, minus 3 sine x minus cos x into minus 2 minus 2 into, we have for this term it will be sine square x plus cos square x, like this. So if we solve, we'll have equal to 3 sine x plus cos x, then every cos square x plus sine square x gives us 1. Remember the identity. So this dissolves to 1. Minus 2 times 1 is minus 2. And now have plus minus 3 sine x minus cos x, okay, into this also resolves to 1. So you have minus 2. So when we open the brackets, we're going to get minus what? 6 sine x minus 2 cos x. Then when you open the brackets, minus 2 times minus 3 is going to give you plus 6 sine x, and minus 2 multiplying this term is going to give you a plus 2 cos x. So we find out that when we collect the like terms, minus 6 sine x plus 6 cos plus 6 sine x is going to give me 0. Minus 2 cos x plus 2 cos x is going to give me 0. So the Wronskian of the following terms, as we saw above, the Wronskian of sine x, 2 cos x, 3 sine x plus cos x. Is equal to 0. So since we have determined that the Wronskian is equal to 0, therefore sine x, 2 cos x, and 3 sine x plus cos x are linearly independent. Dependent. So I think this is for this problem, and I hope you understood the steps and the procedures. So remember, sine squared x plus cos squared x is equal to 1. So this is one of your keys when you're solving for the Wronskian of trigonometric identities. Is that okay? Functions. So I'll leave it here. We've done quite exhaustively in finding the Wronskian of different functions. So I hope you'll be able to reproduce the solution of this problem on your own, and even go ahead to attempt different problems with different difficulties. So one of the advices is that you need to be careful the choice of row or column that you decide to expand your determinants from. Okay, and there are various techniques you learn about simplifying determinants when you do linear algebra or probably later in the future, but try to expand from a row or from a column that will simplify your work. If you don't see any term or any zero row or any zero column or any column that has zero or any row that has zero, you probably want to go for the column or row that contains like the fattest expression of terms. That is why I went for this one over here. It has like the fattest expression of terms, while these other ones are just 1/110. So it makes it easier for me to simplify it, as you can see on what we did here. So if you still have questions, please post it on the comment section or reach out to me, and I will be glad to attend your questions and provide answers as soon as possible. So please like this video, share, subscribe, hit the notification to stay updated, and see you in the next video.